Hey guys, welcome back to a new video, and actually to part 2 of our Ktor chat app series, in which we will now build the actual Android app. So in the last part, you actually built the Ktor server, which we also needed to make this app work, and now we are actually going to build the actual app. You can see this is how it will look like, which you probably already know if you watched the last video. In case you missed that, then you can click somewhere here, and I will link it, because otherwise watching this before part 1 doesn't make too much sense, so I really recommend watching part 1 first and then jumping to this one. However, there will still be a part 3, so you also don't want to miss that, in which we'll actually deploy the server, so you can also use the chat like a real chat and not only in your local network. And at this point, I want to thank my sponsor, Hostinger, who will provide the server we will actually deploy this chat application to. They currently have a huge Black Friday offer here on their website. You will find the link down below, hostinger.com. So in case you actually also want to deploy your app and you want to use that with your friends, which totally makes sense, then you can find their different plans here on their website. And once you decide for a plan, you can see they really offer a lot, like up to 100 websites, lots of storage. Once you decide for that, you can simply click select here. Then you will get to this order page. You can pick your billing period that you prefer, enter your details, payment methods. And what you don't want to forget here is to actually click on have a coupon code, because you do have a coupon code. If you're watching this video, you can simply use the code Philipp7. And then you will get additional 7% on top of that even very cheap price, which is just $2 a month for a server you can just deploy your backend to, and that's pretty cool. Once you're then logged in, it will look somehow like this. So this is basically your web interface in which you can manage all your servers. They also have a very great web hosting plan, shared web hosting. If you decide to have a website, then I can only recommend having that as here on Hostinger. You can have a domain. You can see I registered a domain here, which is currently very empty. And I have a VPS server. That is what we're going to use to deploy our chat here to. VPS stands for Virtual Private Server. It's in the end just a virtual machine, a remote Linux machine where we have root access to. So we can install all the stuff we need on that server, like MongoDB, for example, and then simply use that to, chat with our friends together. So that's pretty cool, and I'm looking forward to that. Let me quickly show you the initial project setup, which you can, by the way, get from my GitHub repository. So just check down below. It's really only Gradle configuration and Gradle dependencies. So yeah, just copy these over. We have these two class paths here for Kotlin serialization to just deserialize and serialize JSON from our server. So in the end, our messages. The Hilt plugin, so we use dependency injection with Dagger Hilt here. We have our built at Gradle app file with the plugins applied, of course. And let's take a look here. Compose dependencies for view models and navigation, routines and view model scope, Dagger Hilt. I think that's all not a surprise. Maybe this one requires a little bit of explanation. That is Ktor client. So we will make network requests with this, with Ktor, not with retrofit or anything like that, because retrofit does not support Websockets. OKHTTP does, but it's quite a pain to make that work. And with Ktor client side, that's actually a lot easier. So that's why I included these dependencies here. And of course, Kotlin serialization as well. The logging here is optional. So in case you want to see what your client actually sends and receives, you can include that. If not, just leave it away. Let's actually jump right into it. We will use clean architecture here, mostly at least. So I will actually leave away the use cases here, because I think in this app it's really just making our code messy, because it just introduces a lot of boilerplate. We don't need these really. They will just call repository functions. So if you really want to learn the whole picture of clean architecture, then I recommend you to watch either my Node app course or my dictionary course on that. Let's actually start by setting up the project structure here. Going to our root package, creating a new package. Let's start with data. So we will have the data package, the remote package in that for our API stuff, and a DTO package in that for our network models. Then we will have a domain package, domain.model, in which we'll have our domain model, surprise, surprise. Which will also just be a message in this case. And we'll have our presentation package, in which we will, on the one hand, have a username package for our username screen, so the username screen and the username view model. And we're going to have a chat package for the chat screen and chat view model. And finally, I think the last package we need is a DI package in our root package for our app module, so for everything regarding dependency injection. So let's actually start writing some code. I want to start setting up our DTO class, so our message DTO, which will be the Kotlin class that represents the JSON data we get from the API. So right-click New Kotlin class in the DTO package, and I'll call it message DTO. Like data class here. Yep, let me add that to Git. We want to make sure to annotate this with @serializable. So we just make sure that Kotlin X serialization is able to serialize and deserialize this class. And in there, we will just have the same variables that we actually get from the API. So on the one hand, the text of the message, we will have the timestamp of type long, we will have the username who wrote that message, and we'll have the ID. That's pretty much already it for this. Step number 2 is actually to create the domain model of this class. So that will represent all the fields that we will need in our UI. So for example, this ID is not really needed in our UI layer, so we can simply leave it away in that message domain model. And also this timestamp should not be displayed as a long in the UI layer. So we will kind of format everything for that domain model. This is debatable. You could also leave that along and also then format that in your UI, which would have the benefit that you could format that depending on where you display it. So at some places you could have a different time pattern than on other places. However, here I like to put that in the mapper function. So the formatting logic, it's debatable. You could do both. So let's actually go to the domain model, a new class, which will be called message data class. We'll definitely need the text to display that. It will need the formatted time, which is now a string, and it will need the username. And that's pretty much it for this domain model. Now, something we do in clean architecture is that we define these mapper functions. So the mapper function will take such a DTO object. We're now going to map it to a message object from our domain model package. So that will return a message. We can say return message. Text will be just text. Timestamp will be, actually no, we didn't call it timestamp. We called it formatted time. And here we now want to pass a string. So this is now the place in which we format the time. So we don't need to do that in our UI layer. We can do that using the date and times API, I think it's called. So we first of all define a date, which we can say new date, Java util, and we pass our timestamp here. Then we can actually use that date and format it to our desired pattern. And we can do that using val formatted date is equal to date format. Actually from java.text get date instance, and we call that format passing our date. You can also pass a style here, so how you would like to format this. So you could say date format dot short, long, default. I think I'll leave it at default. Not sure what that will lead to. Yeah, let's just do this. We'll see later in our UI. Then we can assign that here for our formatted date. And the username will just be username. So far for our mapper function. So what is now the next step? The next step is to actually create our API. So on the one hand, we will have our API that will just make the network request to get all messages that are already in the chat. And then we're also going to need some kind of Websocket service, because we of course need to listen to all these real-time messages that could potentially come in and display them in our UI. Let's actually start with the simpler part, which is the API interface. So in remote, new Kotlin class or file called message service, select interface. And here we'll just have a single suspend function called getAllMessages, which will return a list of actually message, so our domain model now. And then we can have a companion object here to define our base URL. So const val HTTP base URL. I'm calling it HTTP base URL. Or let's actually call it base URL here, because we will essentially have two base URLs here. Because for the WebSocket protocol, we have a different schema, I think it's called. So instead of HTTP, we say WS. And for that, we just need two different types of URLs. But since we are also going to have another interface for the socket service, we can just define it there. So the base URL here will just be HTTP. And here we want to pass 10.0.22, followed by our port, which is whatever you chose in Ktor. I chose 8082. The default one is 8080. You can also choose that. And if you want to try out your app on your phone, you need to swap that out with your local IP of your computer, basically. Because this is now set up for the emulator. So if your Ktor server is running locally and you run this app on your emulator, it will work that way. So on the emulator, we can't just say localhost, because that will refer to the emulator's localhost, and no server is running on that. So instead, we say this. If you swap this out with your local IP of your computer, then that would be, I think it would be this in my case. You can find this out by typing cmd here and writing ipconfig, pressing enter, and you want to check for your main Ethernet adapter or Wi-Fi adapter, and here you see this is your local IP address. So you can simply enter it there, and then it will work on emulator and your Android phone, if it's of course logged into your network. And something I will do here is I will define a sealed class called endpoints, which will take the URL as a string parameter here. So that will just define the different endpoints we have. Here we only have a single one to get all messages, but in case you have more, this is a pretty convenient way to actually define these. So we want to have an object here called getAllMessages. Will be of type endpoints. And here we just specify the URL for that. So everything that comes after the base URL, or rather with the base URL together. So we can say base URL / messages it is. And that's pretty much it for this interface. We now want to create an implementation of that in which we just tell how we want to make this API request. So in the network, in the remote package, I mean, let's create a new class called message service implementation. And that will implement that interface message service. Here we want to make sure that we actually have access to our API, which will be of type HTTP client. Actually, let's call that client rather. So that's coming from Ktor, and we can use that to make network calls. We can press Ctrl-I or just implement getAllMessages that way. And now, let's actually do that. Okay, when it comes to making network calls using the Ktor client, that's pretty easy. We can simply return a try and catch block here. Since we want to catch exceptions, in case something goes wrong, then we just want to make sure our app does not crash. In that case, I won't do any proper error handling here. I'll leave that up to you as a little homework. So we can just return an empty list. And in the try block, what do we actually want to do? We want to use our client now, .get, because we want to make a GET request. We want to get the list of messages that are already in the chat. So just pick any of these, like GET. Now we need to specify the type of object our response actually contains. That's in the end a list of message DTO. And in here, we need to put the URL. So at which URL we actually want to get something from. That is from our message service endpoints. getAllMessages.url. And then we can say that map on that, because we don't want to return just messages. We want to return, we don't want to return message GTOs. Instead, we want to return messages. So we want to map the list to messages. That's it. You can see the error is gone. And that's really how easy it is now to make a network call with Ktor. So for the next class, or interface rather, we will build, I will paste a little utility class here that I use in all of my projects. And that is also why I simply paste that here and don't write that from scratch every single time, because those who watch my playlists will know that class. I'll put that in another package called util in the root package, and it's simply called resource. So just to quickly explain this, looks super complex, it actually isn't. It's just a wrapper class around any type of object. You can see it's a generic class, and we can simply use it to distinguish between error and success case. So if we have a successful response, then we can simply emit such a success resource with the corresponding data. And if there is an error, then we can attach an error message. So that will just help us later on in the view model to distinguish between a successful and an error case. And now we're going to need that in another interface we will create in a remote package, which I will call chat-socket service. So this interface will now deal with the whole socket connection. It will send messages to other people, and it will also deal with receiving these. So we can simply observe that later on in our UI. So let's think about what do we need. First of all, when it comes to WebSockets, we want to have a function that actually initiates that WebSocket connection. So other than just having plain HTTP requests, with WebSockets, we actually have that continuous connection to the server. So we actually need to establish that once, and then we hold it. And as long as we hold it and don't close it, we can send messages to the server and also receive messages from the server at the same time. So we're gonna call this init session. And does that need some parameters? Yep. We actually want to send the username to the server. And this will now return such a resource class of type unit here. We don't want to really attach any type of data here. We just want to know, okay, was initiating the session a success or not? It's really that simple. And we also want to have a function to send a message. So simply suspend function send message. We can attach the message in form of a string. Here we don't really need to return anything. Finally, the last function, actually, we need two more functions. One function is to observe messages. So we actually would like to have that in a flow or so, that we can simply, just having a flow that triggers as soon as we get a message. So we want to have a suspend function. Actually, let's just make this normal function because we return flow. Observe messages. That will return a flow from the coroutines library of type message, I would say. And as a last function, I'd like to have one to simply close the session. So for example, when we actually minimize our app, then we first of all want to close the WebSocket connection. So that's what this function will do. And that's already it for this interface. Let's create a class for that and an implementation in our remote package. New Kotlin class called chat-socket service implementation. Chat-socket service. Do we need an argument in the constructor? Yes, we do. And that is our client again. So again, our HTTP client, which we can simply use to initiate that WebSocket connection. We can press Ctrl A to select everything, and Enter to implement all of these functions. So first of all, when we initiate a session, what do we want to do? We actually want to return try and catch again. So we simply want to be able to catch errors. So in case there is an exception, we want to, we can print it if that somehow helps, but we also especially want to return a resource, that error in which yeah, we can just pass the localized message of the exception. If that's null, we can say unknown error, something like that. In the try block, we actually want to initiate the WebSocket connection. And for that, I will introduce a local member variable here, which will be a private var called socket, and that will be of type WebSocket session and null initially. So server side, we already had this WebSocket session. So we will now also have this client side, and we can use it to send something into this connection. So we can send some messages to the server. We can also use it to receive messages. So in here, we can say socket is equal to client dot WebSocket session. So this will return this default client WebSocket session or so. And in this block, we just have a normal HTTP request builder, because when a WebSocket connection is actually established, we still do an HTTP request just once to establish that connection and have that initial handshake, basically. And as soon as that is successful, we have that continuous connection. So we can still build our HTTP request here, where we want to pass a URL. I need to import that, I think. Yeah, like this. Yeah, so which URL is that? I think we didn't define that here in the message service. Yeah, so let's actually copy these two things, like the companion object and the seed class, and also put it here in the chat socket service. So we have a base URL where we will replace HTTP with WS for WebSocket. And for the endpoints here, we will have a chat socket route where we use our base URL and we call chat socket. I think this is how I call it. Then back here, we can say chat socket service endpoints chat socket.url. Now we can check if this socket is actually now active, and if that's true, we want to return a resource.success, passing nothing as the data, and else we want to say resource.error. And for the message, we could say something like couldn't establish a connection, something like that. And that is how we basically initiate a WebSocket connection from an Android device to a server. Let's take a look at the next function, which is to send a message. Also quite easy. We just have a try and catch block. If there is an exception, we just say print stack trace. You could now work on that to forward that to the UI and display that in some way. But for this really simple app, I'll leave that up to you. As I said, in the try block, what's more important here is that we want to now use our socket. And if it's not null, we want to send a frame into that. So we had these frames before. We want to send a text frame. And we can simply attach our message. And that will now be sent into the socket, which is which represents the connection to the server. Next step is observe messages. So this will now return a flow of messages, which should trigger every single time we get a message here on this client. So again, return try catch exception. We will just say print stack trace, and we want to return an empty flow like this. And in the try block, we want to actually get the messages and convert them to a flow. How can we do that? We want to say socket dot incoming, because those are the messages, well, that are incoming. Then we can now, well, let's actually take a look what that is. That is a received channel of type frame. And we now want to properly map this so that we get a flow of type messages. So what we can do is we can first of all call receive as flow. So that will already give us a flow of type frame. However, we want a flow of type message. So first of all, we want to make sure that we only receive text frames, because we know every message is a text frame, it's a JSON string. So we can say we filter these incoming messages by their type. So we only want to be able to get something here that is actually a frame.txt. And the rest will be dropped. Then we can say we want to map this. So now we can be pretty certain that whatever comes in here, whatever frame, is always a text frame. Now we want to get the JSON data. So val.json is actually it as frame.txt. That read text, that's null, we're just going to assign an empty string, will never happen here because we filter for that before. And now we can take this JSON string and convert it to such a message object. So val message DTO is equal to JSON, which comes from the Kotlin X serialization library, dot decode from string. And here we just want to be able to pass a string. We want to parse that to a message DTO object, passing our JSON string. And since we would like to have a flow of messages and not message DTOs, we can simply say message DTO to message. So far, so good. We still have a big error here. The simple reason for that is just that this is not a nullable flow, and this could be a nullable flow. So in case that's null for whatever reason, then we can simply return an empty flow. And there we go. So we get rid of our errors. And the last thing is just to close the session, which is the quickest thing ever. We can just say socket.close. It's that easy. And we've already built our WebSocket service here, which we can then use to actually initiate and maintain that connection. Okay, before we actually jump into our view models and implement the state mapping logic and stuff like that, I actually want to set up Dagger Hilt and dependency injection. So inside of our DI package, we will start defining our app module, new Kotlin class, and this will just contain the dependencies that we want to be able to provide. So we annotate this with app module, with install in. We can install it in the singleton component to make all these dependencies singletons, or rather live as long as our application does. So which dependencies do we actually want to provide here? On the one hand, we want to have a provides function and a singleton here for our HTTP client. So provide HTTP client will return an HTTP client from Ktor. And we can say return HTTP client, where we need to pass an engine. So in a previous video where I showed Ktor with normal network calls, I used an Android engine here. However, for WebSockets, this does not work because the Android engine does not support WebSockets. This is why we use the so-called CIO engine here, just a different one. Doesn't matter, it will work. And in here, we can then configure our client so we can install different features, like logging, for example, like this. Like, what else do we need? We need WebSockets, obviously, so this feature. And we need serialization, or is it called, I think it's called JSON something, JSON feature, like this. And we then can simply configure that. We can say the serializer is a new Kotlin X serializer, just like that. So that's already it to construct our HTTP client. Let's see what's next. So down here. And that's in the end just our message service and our chat socket service. So it provides again, singleton provide message service. It will actually need an instance of our client to construct that. And we can return a message service implementation here, passing our client. We can then copy that, paste it here, and we also want to do the same for our chat socket service. It also needs the client. Here we return a chat socket service implementation, and that's already it. At least for the app module. Let's now create our application class, because that's also needed to be able to use Dagger Hilt. In the root package, new class called chat app or so. Press enter, make that inherit from application. and simply annotate it with @Android app. That's already it for this. Now we need to register that application in our manifest. So let's open that next. First of all, let's not forget to add internet permission here so it doesn't crash because of that later. And then we want to say name is chat app. Cool. That's it for our dependency injection setup. Next up, we will spend time for our view models, starting with the username view model. So in our presentation package, username, new Kotlin class called username view model. I'll select file here, use my live template, hill view model, and we'll call this username view model. Does that need any dependencies? Actually, not really. We will only need our socket service and the message service in the chat view model. So we can simply leave the constructor empty. And we want to make sure that we actually have a state here for the text field content. So that will be private val. Well, how do we call that? Username text. And that will be immutable state of just empty here. And we have a public version, immutable one. Also username text is, yeah, just a state of a string and equal to username text, just like that. Then something we need is a flow, like a shared flow, that is actually triggered when we successfully join the chat. So we actually want to validate that text field. That's why we'll introduce that. So in case there's an error, we can simply send something into that shared flow, or rather the other way around. If there are no errors, we send an event into that shared flow that we are now joining the chat so we can navigate in our UI. And if we don't get anything, then yeah, there might be an error. So again, as I said, I won't spend a lot of time here for very detailed error handling. I'll just make sure it doesn't break. So I will actually say private val on join chat. And that is a mutable shared flow. What do we send into this? Well, let's just send the username into this. So string, we can have another public immutable version of that, which is on join chat as shared flow. And then let's actually have a function. First of all, when the username changes, so on username change, here the new username. And here we can just say username text.value is the new username. Then let's have a function to actually handle click events on our join button. So on join click, we want to launch a coroutine in view model scope. And well, what happens in here? All I really want to validate here is that it's not an empty field. So if the username text.value is not blank, then we simply want to navigate. As I said, you can do a lot more validation work here, which I'm not going to do. So we simply want to say on join chat, emit, and we emit the username text.value, so the current username. And that's it for our view model. Pretty easy here. The next view model will be our chat view model. So let's do that. In our chat package, new Kotlin class of file. I'll select file here and call it chat view model. Build view model here. I actually have a video about these live templates, so you won't have these by default. If you haven't watched the video, of course. I'll call this chat view model. And this will now take actually 3 parameters in the constructor. On the one hand, our message service. On the other hand, our chat socket service. And it will also need the saved instance state. The saved instance state is something Hild is able to automatically inject in view models, and it contains information about the currently saved state, you can say. Luckily, it also contains information about the navigation arguments that we passed. Because in the end, what we need here is the username that we chose. And we need that only in the view model to initiate that request. So that way we don't need to pass that username from the UI to the view model. Instead, we can directly get it from the saved instance state. So val message service, first of all. Then we do have a val for the chat socket service. And we do have a val for the saved, oh, I said saved instance state. It's actually saved state handle, sorry. Saved instance state is something related to fragments and activities. Saved state handle actually also restores the state of a view model, for example, after process death. So build is able to inject that here. We don't need to provide that anywhere. So we're actually now good to go and ready to implement the logic here. So let's actually think about what kind of states we need here in this chat view model. And for that, I'd like to actually create a wrapper class, a chat state in our chat package. So new Kotlin class called chat state, which will kind of combine the states that we need on the screen. On the one hand, that is our list of messages, list of message. From our domain package will be an empty list. And we have an is loading boolean, which I'll set to false initially. We'll also have a text field state for the chat input, like the message input text, which I will make a separate state because that is changed quite often when we type something, and then we want to prevent that all of our screen recomposes so often. So first of all, let's have that, our message text state, which is a string and initially an empty string. And then we have another state, which is just our normal chat state here. So we make that of type chat state as an empty chat state by default. And there we go. One more thing we need is actually also such a shared flow, which we also have in the username view model. In this case, for potential errors. So I will just call this like toast event. So we are just going to display simple toasts here in the UI when there is something to display. We can say mutable shared flow of strings. So we send messages in that. And then we say toast event is toast event.as shared flow. Just like this. So we also have an immutable version. So let's just start to have a function that changes our message text field state. That's probably the most simple thing here in this class. Function on message change. We pass the new message here. And we say message text at value is just the new message. So far, so good. We need quite some more functions here. On the one hand, we need a function to actually disconnect from the chat. So function disconnect. And here we're just going to launch a coroutine in a view model scope. And we can say chat socket service.close session. That's pretty much everything we need to do. We could then also call this in onCleared. So as soon as the view model is cleared, we would like to disconnect. Then we also need some kind of function to send a message, which is also pretty simple. Send message. We don't even need the message here because it's contained in the state. So view model scope, launch, chat socket service dot send message, and the message will be message text dot value. And we actually only want to send this if this is not null. So if message text dot value is not blank, then we're going to do this. Okay, that's already it for that. So what's missing? It's definitely missing to retrieve the messages from the API, so from the message service. And it's necessary to initiate our WebSocket connection when we create this view model. Let's start with retrieving our messages. I will create a function for that here. Function get all messages, which is a very simple function as well. Just launching a coroutine in view model scope, in which we first want to set the state at value to state value copy, because now we can say that we're loading. So we can say state.value.copy to take a copy of the same state, and we change the loading value to true. Then we can say val result is message service get all messages. And after that, after we got the result, we can again say state.value is state value copy. This time we also want to change the messages to our result, and is loading is now false. So far so good. That is how we actually get all messages. We can now call this in our init block to initially fire that off, that request. And when the request then succeeds, our state will update and our UI also will then update. And now all that's missing is to actually initiate the WebSocket connection. I'll just do that down here. For that, we need to know the username because that must be contained in the actual request. Now that I think about it, I don't think I actually included that in the ChatSocket service implementation. No. So here where we pass the URL, yeah, let's leave it on one line. We actually would like to include that here as a Kotlin, just in a string. And after that, we have a question mark username is equal to whatever we passed for that username. So that's how we just pass that query parameter. So this one here. And our server actually knows which username we chose. So back in chat view model, we can then say saved state handle, which now contains that username navigation argument. That get, we're going to get a string called username. Make sure it's not null. And if it's not null, we launch a coroutine in view model scope. And we can now initiate that connection here. So we can say ChatSocket service init session, passing our username. We get the result here, which is now a resource. If everything went well, it's a resource.success, else it's an error resource. So we can say when result is resource success. Come on, resource, resource.success. In that case, we want to actually listen to changes in that socket connection. If, however, it is an error, we want to send the error message into our toast event. So toast event.emit result.message. If that's null, we just send in unknown error. In the success case, that now gets interesting. As I said, we now want to take our ChatSocket service and we want to observe messages. That now returns a flow, which is triggered every single time we retrieve a message. So what do we do with this flow? We want to call on each. So this is triggered with every single emission of that flow, with every single message that comes in. Here we get the message. And now we want to construct a new list. We want to take this message and add it to the very start of our list. Because how we will do this in the end in our UI, we need to think quite from a different perspective here, because a chat is actually a reversed list. Because the new items will actually come at the very bottom, but we want to be able to scroll up. So if in a normal list we would scroll completely down, that would be the start of the chat. That would be where the latest message appears. In the end, we will use a reverse layout for that from a lazy column, which is really not difficult. But if we actually want to add a message at the bottom of our screen of the chat, we have to add that as a very first item because it's in the end a reversed layout. That's all I'm really trying to explain here. You will see how that works when we build the UI. So we can say val new list is actually state value messages to mutable list. And we can say apply. And here in this mutable list, we can simply add a new item at a specific index. We want to add it at the very first index. I want to add our message. And then we can say state value is state value copy, saying, okay, the new messages is just our new list. And that's really everything we need to do here. Just don't forget to launch this here in view model scope. And yeah, that's pretty much it, I think, for this view model. So all that is really missing now is the UI. So let's start with a more simple screen here, which is the username screen. This is really not a lot. And then get over to the chat screen, which is a bit more complex, but also not too complex. So in our username package, we create a new file called username screen. Select file. We make this a composable called username screen. And this will, on the one hand, take a reference to our username view model. We can say that is equal to hilt view model. And it will take an onNavigate function just in case we navigate to the next screen. We could even just, yeah, let's pass a string instead, just as the route we want to navigate to. Just like this. Then we first of all want to have a launched effect block, passing true for the key. The reason why I'm doing this is because we want to listen to these on join events in the view model. You know, username view model. We have this event, the shared flow. And whenever we join, we send the username into this shared flow. So here, we want to listen to these changes, view model, on join chat, collect latest. And here we get the username, where we can simply say, okay, we call onNavigate with the chat. So that is the chat screen route. We can call it chat screen. And we pass the username as a navigation argument. This is really simple. So let's build our actual UI here. First of all, we want to have a box. Because in the end, we just have a text field that's centered. Actually, a text field together with a button. So let's have a box. Attach a modifier. We make sure that we fill the whole size of our screen. And we can add a little bit of padding here of 16 dp. And we can say the content alignment is center. Then here we can have our column that will be centered in the end. Do we have a modifier here? Yeah, let's do it. Modifier is modifier fill max size. And we say the vertical arrangement is center and the horizontal alignment is end. So this will now accomplish that we actually, do we have this open? That the button will stick to the very end. And since the text field fills the whole width, it doesn't really stick to the end because it just fills the whole width. And inside of this column, we first of all have a text field. The value will be viewModel.usernameText.value. And let's actually rearrange this a bit. On value change will be viewModel. On username change. I'd like to have a placeholder, which will be a text composable, and that just says, I don't know, enter a username. And we say modifier is modifier fillmax width. Just like that. Then we can have a little bit of space. So spacer with the height of, let's say, 8 dp. And we are going to have a button. When we click that button, what should happen? We want to call viewModel on join click. And the text should just say join, I guess. And that is already it for the username screen. Very, very simple. Next up, we will create the chat screen. And as I said, that will be a bit more complex. Let's do that in the chat package. Call it chat screen and select file. Composable chat screen. It will need a reference to the viewModel, the chat viewModel this time, build viewModel. And it will also need the username that we passed. You might wonder why we need this, because we actually get this in the viewModel from the saved state handle. However, we also need this in the UI itself, because when we retrieve a message, we need to decide how we display it. So if we take a look here, okay, not working right now because my server is not running, but if it's actually our own message, then we display it in green and on the right side, and else in gray on the left side. And to determine that if it's our own message, we need to check if the username, our own username, is actually the same as the username of the message that came in. So let's again start with the more simple stuff here, and that is simply having this launched effect block to simply display toasts when we get these toast events in our shared flow from the view model. So we can say view model toast event collect latest. Here we get the messages, and we can just say toast make text. We can pass context that we don't have yet. We can pass the message. We can say toast length long, and that show. To get the context, we can do that in here in the composable block is equal to local context.current. Just like that. The next thing we want to do that isn't directly related to our UI is we kind of want to intercept the onStart and onStop event, because in these events we want to, on the one hand, initiate our WebSocket connection, and on the other hand, in onStop, we want to close it. In Compose, when we want to intercept these onStart and onStop events, like all these lifecycle functions, we need a disposable effect. This is another type of effect handler we don't want to pass through here, that is used to properly handle callbacks in Compose. Because in the end, we're going to get the lifecycle owner here from lifecycle owner, local lifecycle owner, this one, that current. We want to pass that as a key here. So whenever that changes, the block here will be cancelled and relaunched, the coroutine here. Inside of this, we want to have an observer. This observer will be used to actually listen to these changes. We don't need object. We can just say lifecycle event observer. Here we get these events then. And with these events, we can say if that is actually lifecycle event, import that on start. So if we have an onStart event, what do we want to do? Well, we want to call our view model dot connect. It seems like I forgot to create a function to actually connect to the chat, but we actually did this, didn't we? Like all the initiating logic here. Oh, I realized, okay, I put it in the init block. This is not what we want. Let's just make this a function, connect to chat instead. Just like that. Because we don't really want to call this initially. Instead, we want to call it when onStart fires. So also if we minimize and reopen the app, then we will also connect back to the chat. We also want to have an else if block here. So else if event is equal to lifecycle event on stop. Because in that case, we just want to say view model disconnect. Then after this observer block, this lifecycle event observer, we can say lifecycle owner, lifecycle add observer, and we pass this. And then each disposable effect needs to be closed with this onDispose function, which will be triggered when the observer should actually be cleaned up. So when the scope here is basically relaunched, then we can say lifecycle owner, lifecycle remove observer, passing our observer. Just like that. So that makes sure that we properly connect and disconnect to and from our WebSocket connection. We then want to get a reference to the state from our view model. So view model state value. And I would say we can start implementing our UI. So in the end, our UI will just be put inside of a column, because we on the one hand have our lazy list, which is just the list for our messages. On the other hand, we have the text field at the very bottom to enter a new message. So these two elements, the lazy list and the text field, will be put in a column. And yeah, then we just need to worry about the text messages, because that's a bit more work if we want to have these message bubbles, but you'll see how this works. So in here, let's have that column. Modifier is modifier fill max size. And I'd like to apply some padding here. Just like that. Then in here, I want to put a lazy column. Let's also attach a modifier. Let's say modifier dot weight 1f. So that weight modifier will just make sure that the lazy column occupies as much space as it can. So the other way around, the text field will just take some space, and the rest of the space will be for our lazy column. We also want to make sure that we fill the maximum width of our screen, and something that I already mentioned is the reverse layout. We want to set this to true. So it will just reverse the layout that we actually need to scroll down to see the previous messages. So it's just a normal list in reverse. And then we can open this lazy column block. Then here in this lazy column block, I first of all want to have a single item for a little bit of space. This right now won't make any sense while we have a spacer of 32 dp here. It will make sense as soon as we create these items, so the actual message items, which will come right afterwards. So we want to have an items block, and we will now have such an item for every single message in our list. So we actually want to make sure that we choose the items block here that takes a list of t, passing our state.messages, and this gives us access to every single message. Now we can take this and construct a composable out of that, which is a bit more tricky because we would like to have these message bubbles, as I said, and these will also look differently depending on if it's our own chat bubble or someone else's. So first of all, I want to have a variable if this is our own message. So if we should display that on the right side or on the left side. And we can get this boolean by saying message.username is equal to the username we passed here as a parameter. So that is our own username, and that is the username that basically who sent the message. And if that's the same, well, it's our own message, and we want to display it on the right. Then each message will in the end just be a box. And for each box, we will say the content alignment is if is our message alignment dot, well, if it's our own message, we want to align it to the center end. Put this into separate lines, and else alignment dot center start. We want to make sure that the box occupies the whole width, so modifier fill max width, and then we can open this block of code here. So for each individual message, we use a column, because a single message is just, it's basically just three texts on top of each other. So we have the username, then the message text, and then the time, so the date at which we send the message. So let's have this column in here. Let's first of all write the text here because that's easier. So the first text will be the username. So message.username. And we could say the font weight is, let's say, bold. And align these, format that a bit. That. Then we want to say the next text is the actual message, so message.text. And I think we should also make all these messages white. So let's set the text color to color white, and copy this, and simply paste it here. And have a final one for the actual date. So luckily we already formatted that in the mapper, so we don't need to do that here. So we can say message formatted time, color is color at white. And for the last text here, I also want to add a modifier to just align this to the end. So modifier.align, and we can pass end here. Actually, alignment.end. Just like that. So that's the content for the message. However, that will now look not good. So we want to make sure that we actually have a message bubble. And for that, we need to go inside of this column. So in the end, the way this will work is we have to use Canvas for that. We just have this custom drawing because we want to have this little triangle at the bottom left or bottom right corner for each message. And let's actually do that with a modifier. We can apply a canvas using a modifier. First of all, let's make sure that we have a fixed width of 200 dp. So the messages don't occupy the whole width of our screen, which will look quite bad. And then we can say draw behind. So this will now give us a draw scope, which is basically a canvas. And here we can now define our draw logic, how we actually want this triangle to look like and where it should be. So in the end, it's really just a triangle, and then we give this column a background color with a little border radius, and that combined with this triangle will then look like the chat bubble. So let's first have a variable for the corner radius. Corner radius. I'll set this to 10 dp.2 pixels. We will have a variable for the triangle height, which is 20 dp2 pixels. And we're going to have the triangle width here, which is 25 dp2 pixels. Those are just values that I played around with and that look quite cool. Because with these we can now make some calculations to actually draw the triangle at the right point. So we can say the triangle path, because in the end we have to use a path for that, because a triangle is quite a custom shape and there is no function in this draw scope that already gives us access to drawing a triangle. So we need to make a path for that, is equal to path from compose.apply. And now we have to distinguish. If this is our own message, the triangle should look different than if it's actually someone else's message. So let's start with its own message. Now we basically need to move, you can say we have to move the pen to the spot where we want to start drawing the triangle. So let's think about where this point is where we actually want to start to draw. So if this is actually our own message, this is in the bottom right corner. So we want to move this to size, which refers to the size of our canvas. So size.width to the width of the canvas. And that is it for the x coordinate. And the y coordinate will just be size.height. And we subtract our corner radius here. Because otherwise there would be a little gap which we wouldn't fill with color. That's why we need to subtract that. And now we can simply draw some lines. Let's first of all draw a straight line down. So line 2. We don't move the pen on the x-axis. So we say we stay on size.width, but we move it to size.height plus our triangle height. So that's how we draw a line. We want to draw another line. Actually, this time we want to move the pen on the x-axis as well. We're going to say size.width minus triangle width, and we say size.height minus corner radius. Just like this. I know this is quite confusing if you've never dealt with Canvas before. I actually do have a very, very detailed Canvas course. You can find the link down below in this video's description. It's on my website. It's a paid course, but it's so detailed. You will learn everything about Canvas. This video's focus is not about that. That's why I'm going through this a bit quicker. But here, everything we do is basically we define a path. To define a path, we have different points that we basically connect. And here we define where these points are, which points we connect with lines. And in the end, the finally connected shape will then be filled with color. So then after that, we can simply call close, which will close the path. So just connecting the current line with the first initial line again. And that's pretty much it. Then we can copy this because this will differ a bit. If it's not our own message, then we want to draw the triangle at the left, at the bottom left side. Here, what size that width would be at x equal to 0. This as well. What else do we have here? So this stays the same, so the y-axis will actually stay quite unchanged. Here, for this x value, we actually have the triangle width. And for this y value, we actually don't need to change anything. So that's how we actually define the triangle path. So depending on if it's our own message or not, we just draw a different path. Right now we don't draw anything because we just defined the path. So let's do that next, right after that. We can say draw path. The path is our path. Oops. Actually our triangle path. And we can make sure that we give it a color, and the color should be, if it's our own message, color.green or whatever you like, and else color.dark gray. That's it for the canvas stuff. So we actually also want to attach another modifier, which is the background. So that will actually, make up the majority of our chat bubble's color. The color will also be what we did here. The shape will be a rounded corner shape. And for the size, we pass our 10dp. Just like that. And then finally, let's add some padding of 80p. So that is it for every single message. We could have also created our own composable for that. But yeah, let's not care too much about that at this point. All that's now really missing is the text field for the messages. So that comes in this very outer column. Let's take a look where this ends. Here. Right here, we would actually need to put the text field. It's a text field in combination with an icon button to send a message. So we can simply put that in a row. We can say modifier is modifier fill max width. And then we have our text field in here. The value will be view model, message text.value. And in onValueChange, we can call view model on message change. We can assign a placeholder to that text field, which would be simply a text composable saying enter a message. And I'd like to give this a weight. So modifier is modifier dot weight 1f. So just making sure that the icon button will get its size, but the rest of the size will be for the text field. So here is our icon button. What happens when we click on this icon button? Then we simply want to send the message, the current message. So view model, send message. And we want to put an icon into this. We can say icons default send. Content description will be sent. And I think this is actually it for the chat screen. This was quite some work. But yeah, the only thing that's now missing is to put everything together in our main activity, together with navigation. So let's open that. We actually want to annotate this with Android entry point as well to be able to inject dependencies into this, just like our view models. So let's now actually just define our navigation. So we say navigation, actually not navigation, just nav host. We want to have a nav controller here that we get with remember nav controller. We don't need any navigators. We can then pass it here, nav controller. And instead of a graph, we pass a start destination, which will be username screen. Just like that. Okay. So on the one hand, we will have a composable for the username screen, which is very simple because it doesn't take any arguments. We can just use our username screen composable here. It does need an onNavigate function. Here we just want to call navController onNavigate or just navigate. And then we have another composable block in here where the route is actually chat screen slash username. So we want to actually get the username argument here. And then we need to define these arguments here in form of a list. A list of nav arguments. Yep. We need to give it a name, which is username. Make sure to choose the same one as here. And then we need to specify a type. So the type of this argument is a string type, nav type.string type. And we make it nullable. So nullable is true. All this stuff should already be familiar to you if you know my typical Compose courses. I have a very detailed video about just navigation, so feel free to watch that. All we need here is a block of that composable in which we will put the chat screen composable. First of all, let's get the username from the backstack entry. It's equal to it arguments get string called username. And yep, it's actually fine if that's null, because we can then pass it in our chat screen. So username is equal to username. Okay, guys, I think this is actually it. And I'm pretty sure there will be something that doesn't work out. That's pretty much always the case when I build these bigger projects here on YouTube. But I would say we just try this out. So what I will do here is I will go to my emulators up here. Select multiple devices because we'd like to launch this on 2 devices. I'll choose Livestream and Pixel 4. Clicking OK, clicking launch, and then yeah, Gradle will take some time building here. And when that is done, I'll see you back. And hopefully it's actually working and not crashing. If it's crashing, then we'll fix the error. Also make sure that you actually launch your Ktor server that we built in the last part. Just make sure that, yeah, it's running properly here, that the port is actually the same as the port you use in your app. And then we can see here as well if everything is working. So I'll see you back. All right, there we go. Both of our apps actually launched, so at least nothing crashed. Let's see if something crashes when we join here or if everything works. Who knows? So I'll join with Philipp here. There we go. Oh, and there's a message. That looks already pretty good. Because I probably added that previously. I don't even know where that comes from, but I already have a database here. Oh, we actually added that message in the last video, I think. So let's also join here with Peter, for example. Click join. There we go. We see Philipp's message. And if we send something like, hi, Peter, send. Oh, and there it is. Okay, we're just missing a little bit of space here, which is fixable very easily. We can also send something like, hi, how is it going? A little bit annoying that this is overlapping the text view. You can fix this in the manifest with some kind of setting, like the soft input mode. But yeah, pretty good. So it seems like everything is working. Let's quickly fix the spacing in our chat screen. So here for this items block, after that, so I mean inside of this items block, but at the very end, right here, we simply want to have a spacer. So spacer of height 32 dp. And let's launch this again, and it should actually work just fine. Also leave these chats here, and we should also see in Ktor that we left. Yeah, you can see switching protocols. That means something changed at that chat socket route because we left that route. Let's see. Let's join again. Oops. Philipp. joining here. And you can see now the spacing is actually perfectly fine. You can join here with any other name. Write something, and there we go. It's actually working perfectly fine. So I really hope you enjoyed making this app. Feel free to extend this in any way you actually like. And also don't think this is finished yet, because there will be a third part which will go live in the next days. In the third part, we will actually deploy our Ktor backend. So I will show you a way how you can deploy your Ktor server in an automated way. So you can just deploy that with a single Gradle command to your Hostinger server. Thanks again, Hostinger, for sponsoring this playlist here. So definitely don't miss this in case you want to actually use this chat with your friends, or you want to use any type of Ktor server with your friends. Then you will definitely learn how you can deploy that in the next part. I wish you an excellent day, and you can also click somewhere here to get to the next part when it is actually live. So obviously I will add that in the next days. So I'll see you back. Have a nice day. Bye bye.